Hi everyone. Today we're going to be talking about direct variation. Now, direct variation is when the x values and the y values have a direct or the same relationship. So let's see how that works. The equation that you're going to be using for direct variation is y equals kx. The y represents a y value. The k represents constant. Yes, I know constant starts with a C and they have a K there. I don't know why they didn't just put C. And the X is for an X value. So the goal of direct variation is to see how the X and the Y influence each other. What you're going to do is with this equation, find any value for X or Y given the constant and another variable. So let's look at this on a graph. On a graph, direct variation are positive or negative lines that go through the point 0, 0. So a direct variation relationship is going to be a straight linear line that goes through the origin, or 0, 0. This one, since it's going up and to the right, this is a positive relationship. So k, or the constant, is going to be positive. Another type of direct variation is going to be negative. So in this situation, k is negative, so the constant is negative. So this is what direct variation looks like in a graph. When we have the x values get bigger, so do the y values. And as you can see, these are lines that we've seen before. So it's similar to y equals mx plus b, which we know as our slope-intercept form. However, in this case, our b is 0. So we don't need to write anything down with that. Instead of writing m for slope, they replaced it with k. So the k is our constant. Even though it looks a little bit different, we have seen this before. Okay, so we've now looked at it on a graph. Let's look at it in a chart. So in a chart, we want to see a direct relationship between the x values and the y values. What I mean by this is that in order to get from 2 to 1, or 1 to 2 when multiplying, I need to multiply by 2. Oh, look, if I do the same thing over here for the y, I have 3 going to 6. In order to get from 3 to 6 when multiplying, I need to multiply by 2 also. So since the relationship from the first x variable or value to the second x value is times 2, and the first y value to the second y value is times 2, we know that's a direct relationship because we are multiplying by 2 on both sides. And it doesn't necessarily have to be the first two numbers. It's always good to check again. So if I went from the first x value to the fourth x value, to get from 1 to 4, I need to multiply by 4. Let's check that over here. In order to get from 3 all the way to 12, I also need to multiply by 4. So this is a direct relationship. It doesn't have to be by the same amount, but we do want to look at the relationship from side to side. We're going from the same numbers on both sides, and they're being multiplied by the same amount. So from here to here, multiply by 2. Here to here, multiply by 2. Here to here, multiply by 4, and here to here, multiply by 4. So look for that relationship. Now, sometimes you need to find the constant. The constant is what the x is always going to be multiplied by. Now, this is a quick equation in order to help you find k. I'm going to be showing you an example in which this equation is not used, but if you want to use it, that's great. So everything is the same here with what the variables mean. K is constant, y is the y value, and x is the x value. So let's take a look at this example. In a direct variation, when x equals 3 and y equals 9, find the value of y when x equals 5. Now that looks a little scary, but we can take this step by step. The first step is to identify the point in the problem. It will be the x and the y values that are by each other. So I see right here, it says x equals 3 and y equals 9. So that's telling me that I have the point 3, 9, where x is equal to 3 and y is equal to 9. Great, I have that first step. Now, I'm going to take my x and my y, and I'm going to plug the numbers into the equation y equals kx. Remember, this was the equation that was for direct variation. So I have y equals kx. And I'm going to plug in my numbers. I see that y is equal to 9. So where I see a 9, or a y, I'm going to put in y. Let's try that again. Where I see a y, I'm going to plug in 9. I don't know my constant yet, but I do know that my x is going to be 3. Now I need to solve for k. Once I know that number, that's the number I'm going to multiply every x value by in order to get y. So k and 3 are right next to each other. I know that that means that they're multiplying. So in order to get that k by itself, I'm going to do the opposite operation, which is dividing. So I'm going to divide by 3 on both sides of the equal sign. 3 divided by 3 cancel right out, leaving my k all by itself. And 9 divided by 3, I know is 3. That's great, I have my k, but I am not quite done yet. Now I'm going to rewrite my equation with my new k value, but I'm going to leave x and y as just x and y. So my equation is going to be y equals 3 times x. Now I know what I'm going to multiply x by in order to get y. And to do that, I'm going to use the new value for x or y and put it in the equation. It's easy for me to say, right? So what I mean is that I need to find the value of y when x equals 5. So I need to find y. I know my constant is 3, and my new x value is going to be 5. 3 times 5, I know, is 15, and I have my answer. So again, the whole point of this is to find something or an equation that you are going to consistently use in order to find an x or y amount on this line. The direct variation is a straight linear line that is either in the positive or the negative direction, and it always goes through 0, 0. Please write down if you have any questions, and thank you for listening.